3D printers are almost a pox on the product design because it allows you to make stuff that you can't otherwise manufacture, but it makes it poorly, but it's good enough to say that, well, look, it's working. Now let's go. And in a lot of cases, you've got to take a big step back to figure out how are we going to actually make this part? Because production quality 3D printers, if there is such a thing, they're very expensive, but mostly it's just because people change the definition of production quality to good enough instead of something that's going to be hold its tolerances for years. Well, you certainly have to look at it and make sure that it can be made through um
Additional
I don't want
means.
to say traditional means. It's not like I'm rejecting the technology and the ideas or something. It's a matter of, is that part suitable to ship to a customer? And in some cases, the answer might be yes. And well, okay, let's go. But but even in those cases, when you look at the product, it's the surface is rough and it doesn't really, the shape is a little funky and it feels weird. Um, where that if this thing was actually machined out of a piece of acetal, um, it would be, you know, rock solid and smooth and easy to handle, and that it would work. Now you're worried, gee, can I break this? And everyone says that it's strong, but they're strong. And then there's, well, let's crush it and see how strong it is. And you find out that it falls apart at 1/10 of the pressures of other materials. And but they're like, but that's good enough because it never has to withstand that pressure. Well, okay. Um, maybe they're right, but they're usually not. There are companies that have acres of 3D printers, and you call them up, and they will send me the file, and I'll ship them to you tomorrow.
Oh, wow. Okay.
So it's fast too, and it's not all that terribly expensive. It isn't scalable though. If you have to go from I need one or I need five, now I need 100,000. Um, it takes so long to make one that, well, we can ship you 100,000, but it's gonna take us 3 years to print it, or we're going to have to add another factory and buy 10,000 machines in order to print this. And so it's not scalable. So you don't get the cost reduction of, say, injection molding. Injection molding, the very first part is $50,000. After that, they're 5 cents a piece. Injection molded, the very first part is $53. The 100,000th part is $53 because it just takes that much time to do it.
A lot of these decisions, like 3D printing, I would say is one option to make a part. Okay, it's a means to making a part. There are others. There's 3D printing, there's injection molding, there's urethane casting. Pick your poison. What informs the decision as to which path you want to take is, I mean, there's a bunch of things, big one being annual volumes, startup funding, all that kind of stuff. We actually just went through this with one of our customers. They were asking us to manufacture a part, and they're a startup company. They have funding, but they're on a budget. So they asked us to explore making this part through injection molding or through cast urethane. And the thing with cast urethane is there's a little tooling up front, but it's minuscule. And then the piece part is, I don't know, call it $20 a piece, right? Whereas injection molding, the tooling up front is $80,000. But to John's point, the parts are 3.5 cents. The problem with that, if you were to put those two cost analysis on the same graph, with urethane cast, you would basically see a linear line from 0 to 1,000. Whereas with injection molding, you would see a similar line, but it would jump initially and then it would go over. And the x-axis there is how many units are you going to build. So that that kind of question has to go to our customer and say, well, what do you plan on building? How long do you plan on building this product? How many per year?
It's not just how many do you plan on building, but how many do you plan on building before you're going to change the part?
Yeah, how frozen is the design? Because once you spend $80,000 in this capital equipment or just the tooling, yeah, you might not want to change things because then you're going to go spend $80,000 again after you've changed it.
Right.
So
The way we handle that is as soon as someone says, okay, we're going to get this part molded, that part now becomes a constraint on the rest of the design. Meaning,
Right.
no, you can't change it. You have to live with that part. So you've got to change something else. If that part, if the product doesn't work with that part, you got to change something else to make it work because that part is too expensive to change.